Now we're ready to draw the graph of the cosine function. We know the sine and cosine are very similar in lots of ways, so we expect something kind of similar to the graph of the sine. And yet we know they're also different. Either their values don't match up or their positive and negative don't match up. So that's what we're going to observe here. What's the similarity and what's the difference? Now, the biggest thing, though, for you to try to get a handle on right now is when we graph the cosine function, our input values, or our x values, you might say, are going to be theta values, angle values. Those are not x values on the unit circle, right? Theta is not an x or a y coordinate, it just represents an angle in standard position. But on this graph that we're drawing now, theta will be the input or the horizontal axis variable. Cosine, it's an x coordinate on the unit circle. It's going to become a y coordinate on the graph of the cosine function. This is something that you really got to try to deal with and get used to, because we're making this transition now. Cosine's no longer going to be an x coordinate, it's going to become a y coordinate on this graph. Now the values of cosine for the special angles, we can pluck off the unit circle. So at 0, cosine's an x coordinate. So we're taking x coordinates on the unit circle. 1 for 0. Square root of 3 over 2 at pi over 6. Square root of 2 over 2 at pi over 4. At pi over 3, the cosine is a half. And at pi over 2, the cosine, the x coordinate, is 0. But now these numbers that we just said were x coordinates on the unit circle are going to become y coordinates of points on the graph of the cosine function. Square root of 3 over 2, remember that was about 0.87, right? Square root of 2 over 2 was about 0.7 for plotting purposes. So again, we have values related to sine, but something's going to be different here. For instance, at 0, we have the point 0,1. We start out at a vertical axis intercept point 1 unit up for cosine. Then, and I already went ahead and labeled the missing radian measures on my horizontal axis. They match exactly with the sine measures here. So 2 squares over is pi over 6. And I want to plot the point square root of 3 over 2. That's about 0.87, right? So that's about here. Also, notice I wrote in a few of the actual coordinates assigned points because we were plotting without labeling them. And I just want to, even though I'm using these decimal approximations, the exact values are given by these fractions and square roots. Pi over 4, it's 0.7, about there. Pi over 3, the cosine of pi over 3 is exactly a half. And at pi over 2, cosine is 0. So I'm coming down from 1 unit up on the vertical axis and coming down toward the horizontal axis intercept at pi over 2. Again, just for the record, this is the point pi over 6 comma square root of 3 over 2. Pi over 2 comma square root of 2 over 2. Pi over 3 comma 1/2. So this 1/2, that's an x coordinate on the unit circle, has become a y coordinate on this graph. Now we're going to continue to go around the unit circle. So next I'm going to work with 2 pi over 3, 3 pi over 4, 5 pi over 6, and I want the cosine. So my next cosine is negative a half at 2 pi over 3. I'm below the horizontal axis. At 3 pi over 4, my cosine is negative square root of 2 over 2. That's about negative 0.7. And at 5 pi over 6, my cosine's negative square root of 3 over 2. So I'm for the second quadrant values for cosine, I'm getting negatives right. And the cosine of pi is negative 1. So the x coordinate here on the unit circle becomes a negative y coordinate on the graph of the cosine function. And now I'm going to continue through third quadrant values, 7 pi over 6, 5 pi over 4, 4 pi over 3. Again, there are many more angles there. I'm just using the special angle values to kind of guide me through this graph drawing process. 7 pi over 6, the cosine's still negative, negative square root of 3 over 2. At 5 pi over 4, it's negative square root of 2 over 2. At 4 pi over 3, it's negative a half. So there's 4 pi over 3. Cosine is negative a half. That becomes a y coordinate here. At 3 pi over 2, cosine is 0. So we're getting a very similar shape to sine, right? But we're kind of staggered in a slightly off way. At 5 pi over 3, my cosine is back to being positive, right? Positive a half. So at 5 pi over 3, I'm at positive a half. 7 pi over 4, positive square root of 2 over 2. 11 pi over 6, positive square root of 3 over 2. And at 2 pi, once I've gone full circle, I'm back to a cosine value of 1. And you might have guessed that this was coming. And just like with the sine wave, we can continue on to 13 pi over 6, 9 pi over 4, 7 pi over 3. So this is like if we've gone more than one full circle, we'll start hitting the same cosine values. We're just back in this first quadrant, right? So square root of 3 over 2, square root of 2 over 2, 1/2. So square root of 3 over 2, square root of 2 over 2. So it's like that, 0.87, 0.7. At 7 pi over 3, the cosine will be exactly 1/2. And at 5 pi over 2, which is one full circle plus pi over 2 more, the cosine is 0. And I hope you see, once you get the basics of this pattern down, you can kind of see where it's going in each direction. It's like we can, I know what the negative points are going to be just from the pattern of the shape of this thing. But let's just think about the unit circle one more time. If we plotted negative pi over 6, so negative 30 degrees, the cosine is positive square root of 3 over 2. So at negative pi over 6, the cosine is actually positive square root of 3 over 2. So that point has coordinates negative pi over 6, positive square root of 3 over 2. And at negative pi over 4, the cosine is positive square root of 2 over 2. At negative pi over 3, the cosine is positive a half. And finally, at negative pi over 2, so negative 90 degrees, coincides with is 3 pi over 2, so the cosine is 0. And here's a cosine graph. And it continues infinitely in both directions. What's interesting to note is the shape of the sine and cosine graphs are the same. In fact, we'll talk about how one is just a horizontal translation of the other. And where's my unit circle here? I want to just compare the cosines as lengths on the unit circle to lengths on our cosine graph. So at 0, it's the x-coordinate. At 0, that's the cosine. So I could draw a horizontal segment in red. I hope the red shows up here. That length of 1 matches this y-coordinate, which is now in a vertical position on this graph of 1. At 30 degrees, or pi over 6, the cosine square root of 3 over 2. Now I could go down to the x-axis, but instead of drawing on top of one another, I'm going to just go straight across this way. So I can draw these lengths like so. That red length is square root of 3 over 2. At 45 degrees, this red length is square root of 2 over 2. At pi over 3, that red length is exactly a half. So notice as the angle increases, these red lengths get shorter and shorter till they're finally 0 at pi over 2. That corresponds to these red lengths on the graph of cosine. So they're horizontal here because they're x-coordinates. On the graph of cosine, they're vertical because they've now they've become y-coordinates on that graph. When we increase past pi over 2, they become negative. Okay. And now we're going to sum all this up in a bit. So this is a lot of detail, and what we're going to do in our next video is just sort of talk about what are the essentials of the graphs of sine and cosine that you just got to know. You'll never have to draw them in this much detail again. I think it's just something we go through once to appreciate where these wave function graphs come from. But this is it. This is step 4. This is the advanced way of thinking of sine and cosine.